Hey everybody, we're back. It's me, it's Steve, the OG, and we're back for more Programming in Basic, and we're on Chapter 13, and I'm excited about Chapter 13 for a couple of reasons. First reason is, actually, I don't know how many reasons there are, whatever, I'm stupid. Anyway, so why am I excited about the fact that we're on Chapter 13? Because when we finish Chapter 13, we have finished the portion of the books that's called the basics. So everything we've been covering are some kind of fundamental building blocks on programming concepts, variables, numeric variables, string variables, formulas, performing mathematical calculations on variables and coming up with new numbers and data and stuff based on adding variables and subroutines. And we've played a little bit with color, we've played a little bit with sound, but most of the stuff we've been doing so far, it's not that flashy. It's not been a lot to look at. I've tried to give us some visual examples whenever possible. So the next chapter is going to be starting in graphics. And so I just wanted to kind of show you a couple things too. Now, the book that we're using for this series is a book I found on the Color Computer Archive, which is a tall, skinny book that was probably reproduced later on for the Coco 2. Now, the book that I started with was actually this book here. And this book was called Getting Started with Color Basic. There was actually two different versions of Basic. So you had either Color Basic, which was the most basic of basics. And then if you had the extra money to either buy it or upgrade your computer, you could then get Extended Color Basic. And Extended Color Basic is what really introduced us to the ability to do high resolution graphics and better sound on our Coco. Internally, if a game was written in an assembly language, the guys who made games in machine language, they were accessing the high resolution graphics all by themselves. They didn't need BASIC to do that. But for me, as a kid programmer, the only way I could do high resolution graphics was to wait till I could get to the point where I could upgrade my Coco to one that had Extended Color Basic. And also, since I've got the big camera here open real quick, time for quick shameless promotions. I've recorded 4 videos so far. I haven't tried to plug anything or hawk anything, but let me do something right now because we are getting ready for Coco Fest, and I do have some cool things I want to share at Coco Fest. So last year, based on a request, I recorded my first ever Coco Games Play DVD for Coco Fest, and this was a DVD I created that has about 2 hours of color computer games and interviews and whatnot. And it's pretty cool retro packaging. And so I had these available for sale last year at Coco Fest. This was the first time I ever made anything that resembled merchandise. I will have this available again this year at Coco Fest. Also available on my website right down here, ogsteviestro.com. You can get it there. But what am I really excited about? What was my project for this year? I have a new DVD for Coco Fest 26. What is cool about this DVD here is that there are 13 gameplay videos on here. Here's a picture of some of them. And these game videos are not available on YouTube, so they're completely exclusive. So if you want to pick yourself up a copy of this one, and look, the DVD looks kind of like a floppy drive, which I think is cool. These are the games that are on it. There are 13 brand new Coco videos that are mostly games I've never even played before, and that are games that are completely exclusive to this DVD, so you'll only get them if you either buy a copy on ogsteviestro.com or buy a copy from me at Coco Fest, which is only a couple weeks away. Now, Nick Marentes is Pop Star Pilot. This is the original package. This is the package we're going to have available at Coco Fest. Now, this insert now is going to be a full color insert. This was our first test, but it is a slight variation on the package, but it's the same game CD. The game CD has a disc image of Pop Star Pilot and a copy of all of Nick's games, including the manuals and artwork for them. So I'm really excited to have some stuff to show at Coco Fest, some new things. Like this DVD I've made is new. And being able to have Nick Marentes represent his awesome game at Coco Fest this year was important to me to try to pull off, and I'm glad we're able to have him have a presence here at Coco Fest. So let's get on to Chapter 13 now. Enough of the babbling. Chapter 13 is called More Basics. Now, it says here, what does it say here? It says, this is... before you're finished with the basics, you need to know a few more words. The first is stop. Type, type and run this program. So we're going to do 10, A equals 1. 20, A equals A. plus 1. Now, here's my other dilemma and challenge. So, where the heck is it? I had brought up, I want to bring this up on screen. Here's a picture of the keyboard layout. And what you can see is that the Cocoa keyboard is listed on the bottom. And where certain things are in the Cocoa keyboard don't necessarily line up to where they are in the PC keyboard. This is how VCC maps certain keys. Now, there is actually an option, and I want to bring that option up on screen right now too. But there's an option to change the VCC setup to change the keyboard layout. And I think I'm going to, let me bring this picture up here real quick. Yeah, so I'm going to bring you up a little screenshot of this that I took. You can go into your VCC options. You can change your keyboard mapping. So the default keyboard mapping is the Cocoa mapping, and the DECB stands for Disk Extended Color Basic. You can drop down from here and you can choose some settings for OS 9 keyboards. I'm going to try that for grins and giggles. I'm going to change my config. I'm going to go to keyboard, and I'm going to choose Natural OS 9. And then maybe I can type like a normal person and not have to look all over the place to see where my keys are. But this is what I've been struggling with, is trying to get like dashes and colons and parentheses, because where they were on the Cocoa keyboard is nowhere near where they are on a real keyboard. So A equals A plus 1. Why is the 1 not working? I got to click back on VCC. Boom. There we go. A equals A plus 1. Okay. Line 30 says stop. Line 40 says A equals A. Oh my God, this is so much easier. Being able to type like a normal person. A equals A times 2. Line 50 says stop. Line 60 says go to 20. Okay, so, and I've also noticed that my fonts look different now too. I don't remember if my fonts looked this way before, or maybe it's because I'm on OS 9. Not exactly sure. All right, so now, when you start running the program, you get a message that says break in 30. And it says now you can type a command to see what's been happening. For example, type in print A. Okay, so it says print A is 2. Why is that? A started with the value of 1. I then told A to increment itself by 1. And then I told it to stop. So 1 plus 1 is 2. When I say print A, it's currently telling me that A is a value of 2. Now it says it stopped in line 30, but we can type in CONT for continue, and it will run another line and then stopped again. So now if I say print A is worth 4. This time the computer prints 4 as A's value in line 50. Why? Because we said A is equals A times 2. If you type continue again, it's going to go back and it's going to stop, and if I print A, I'm going to add 1 to that. If I type continue, it's going to double that. If I print A, yeah, so I could keep going back and forth. So the stop forces your program to exit. Continue tells it to pick right back up where you left off. So it's like forcing a break instead of pressing the break key. And by the way, speaking of break keys, the break key on VCC is the end key. And the clear key, which clears the screen and is also used in certain cases, that's the home key. So remember, to break out of your program, you have to press end. So that's kind of cool that stop will stop and continue will continue here. Now it says for long programs, it says clear memory and type in print mem. How do I clear memory? Do I just type in new? And I type in clear. Okay. Now if I say print mem, how about we do that? 22/8/24. Now what I'm noticing right now, and I don't know if this was me on my program, but it seems like the fonts look a little weird to me right now on my screen. And I'm not sure why. Like, they look a little bit distorted. And I don't know if that's just because I've changed to OS 9 mode. Like if I go back to my keyboard and I change it back to Cocoa and hit apply, does that change the way my screen looks? No, it doesn't. When I do print mem 22/84, I don't know why, but the characters look weird to me today. And maybe it's just me, you know? Yeah, maybe I've done something to stretch the size of the screen that I'm not aware of. If I go to my VCC config, I'm on a composite display. Yeah, I don't know what the heck I'm doing here. That's fine. It looks weird to me, but whatever. You guys will live with it. All right, so print mem. Your computer prints how much storage space remains in the computer's memory. When you're typing a long program, you will want to have the computer print mem from time to time to make sure you're not running out of memory. Now it's asking me to type in this program here. And sometimes I question the programs it wants us to do as our examples, but I'm going to faithfully follow along and then maybe possibly add some value-added commentary if possible. So 10, input, quote, type 1, comma, 2, comma, or 3, end quote, semicolon, n. So it's going to display the prompt, type in 1, 2, or 3, and it's going to input that number into a variable that we will call n for number. Now, on line 20, on n, GOSUB 100, 200, 300. 30, go to, what I'm assuming is going to happen here is if I type in 1, it will GOSUB a routine called 100. If I type in 2, it will GOSUB a routine on line 200. And if I type in 3, it will GOSUB a routine on line 300. So let's give it a shot. On line 100, we're going to print, quote, you typed 1. And line 110, we will return. Remember, anytime you use a GOSUB and you go to a subroutine, you need to return back to where you came from. On line 200, we're going to say print, quote, you typed 2. I guess you don't need the end quote. Line 210, return. On line 300, print, you typed 3, 310, return. So, and so it's basically telling us here in the book that on GOSUB in line 20 works the same thing as this. Like we could have said if n equals 1, then GOSUB 100. If n equals 2, then GOSUB 200. Or if n equals 3, then GOSUB 300. But that would require 3 different comparisons to do it. And it's a little bit less elegant. So on n, meaning depending on what n is, GOSUB a routine. And so we're expecting kind of a numerical sequence. So if it's 1, we'll go to routine 1. If it's 2, we'll go to routine 2, and so on. Pretty cool. So n is the number 1. The computer goes to that routine if n is the number 2, and so on and so forth. But it says, what if n is 4? There's no 4th line number. This simply goes to the next line in the program. So let's take a look at that. Let's try this a few times. If I run it, if I type in 1, it says you typed 1. If I type 2, it says you typed 2. If I type 3, it says you typed 3. If I type 4, there is no GOSUB option for that, so it just ignores that, and the last line of the program has it loop back to line 10 where it just prompts me for something new. So anything invalid, if I do -1, or if I do -1, negative's not working. How do I get to, oh, I forgot I'm back on the stupid Cocoa keyboard. All right, if I do -1, function call error. Okay, so I broke the program, so we can't handle negatives. But if I do 1, that's fine. If I do 2, if I do 3, if I do 4, it ignores it. If I do 0, it ignores it. So as long as I don't do a negative value, because we can't call a subroutine of a negative line number, that makes sense. Okay, that's cool. So you just learned a new option here on X, on variable, GOSUB, routine, X, Y, or Z. All right, so gather a variable somehow. Depending on what that variable is, go to a predetermined number of subroutines. So if you have a variable range of 1 to 3, you could have 3 different subroutines out there and call one of those subroutines depending on what that variable is. That is the whole idea here. Here is a program that uses on and GOSUB. So I guess we're going to hit new and type in a new one. So 5 for P equals 1 to 600. I'm getting used to wherever the stupid old things were. Next P. That's just pausing for 600 cycles. Now 10, CLS, colon. Okay. I might need to go back. I'm going to go back to VCC. I'm going to change my keyboard to OS9 Natural, and hopefully enough of my typing will work. Okay. CLS, colon, X equals RND 100, right parentheses, colon, Y equals RND 100, right parentheses. Yeah, I don't know why it just looks so weird to me the way this screen looks right now. The fonts on my screen look funky. You know what I bet you I did? I don't know what I did. But let me see if I can't stretch this out some on my own, because it's really bothering me. I don't know why, but I'm crazy that way. Okay, whatever. The fonts look stretched and compressed and stuff. They look wacky. I'm wondering if I did something in VCC. I probably did. I probably did something in VCC to make it out of whack. Okay, that looks a little better. I probably resized the VCC window, and I have this weird distortional scaling on the character fonts. All right, I'm so freaking anal retentive about stupid stuff. Okay, so line 5 pauses the program for p equals 1 to 600 next p. So the computer is going to count to 600 until it's done. It's going to keep doing that, and then it will go on to the next line. Line 10 clears the screen, picks 2 random numbers. It picks an X and a Y. Line 30. Oh, what did I just do? Oh my God. Hold on. Holy crap. What happened here? Let's get you back on the screen. All right. Let's do this. I don't know what I just did. Let's get you going. Yeah. Or something. Okay. Now you look like crap again. Oh my God, this is really bothering me. Okay, I gotta move this crap around until the freaking fonts don't look stupid. All right, let me close VCC and try it again. Try it again. The stupid things bother me like that. All right. Here's VCC. Okay. Do my fonts look stupid? Right now my fonts don't look stupid, I don't think. Okay, 5. For P equals 1 to 600. Next P. Okay. 10 CLS, clear screen. X equals random 100. Yeah, natural keyboard, hell of a lot better. Y equals random 100. So line 10 of the program's clearing the screen, picking 2 random numbers, an X and a Y. They're going to be random between 1 and 100. So far so good. 20, print quote. 1 addition, ADDITION, 1 addition. 30, print. 2 subtraction. 40, print. 3 multiplication. I think I spelled that right. Okay. Line 50, print, quote, 4 division. Okay. Line 60, input, quote, which exercise 1 through 4, semicolon, R. It's going to grab the version of arithmetic you want to do there. 70 is going to CLS and clear the screen. Okay, now the program continues. Man, this program's getting big, people. Here we are going to break the computer before we know it. Okay, line 80. On R, GOSUB 1000, comma 2000, comma 3000, comma 4000. And then line 90 says go to 5. So if you pick something that is not within the realm of option 1, 2, 3, or 4, it's just going to automatically go back and ask you to pick something else. Now, we are going to now have 4 different options of 4 different math questions based on what you did. It's going to print out the X and Y random numbers, and then it's going to ask you what is the what is the sum of these? What is the difference of these if we subtract it? What is the multiplication of these if we multiply it? What is the division of these? It will print out the question, show you the numbers, ask you to type in your answer, and then it's going to compare your answer to what the actual answer is and tell you if you got it right or wrong. So kind of cool. This is now more like a real game here. So let's go ahead and do each one of these things right now. So our first one is 1,000. Print quote, what is, end quote, x, then we have to put the plus inside quotes, y. So you're going to see the word what is, you're going to see the value of x, which is random, you're going to see the plus sign, you're going to see the value of y, which is random. Okay, in line 1010, we're going to input a, which is your answer. Line 1020 is going to say, if a equals x plus y, then print correct, else print wrong. This is what's known as an if, then, else statement. So it's actually giving you a couple of options here. If the answer I'm looking for is this, then do that. If it's not this, then do something else. So it's like saying, I'm going to ask you what's your favorite color. If you say blue, I'm going to say, yay, that's my favorite color too. But if you say red, I'm going to say, well, unfortunately, that's not my favorite color. That's kind of the logic there. And it's a very elegant way to do it in one line and not have to do multiple comparisons. So it's kind of a nice all-encompassing logical operation here that says if the answer you picked equals the sum of these two numbers, then say yes, you're right. If not, say no, you're wrong. And then line 1030 should just say return. And it's going to go back. And this is going to be similar for the division, the multiplication, and the subtraction, and everything else. So in line 2000, we're going to say print quote, what is x quote minus, has to be wrapped in quotes, y. So what is x minus y is what's going to go up on the screen. We're going to input a for your answer. Similar logic here. If your answer equals x minus y, then print correct, else print wrong. Okay, that's kind of cool. And then 2030 should return. We'll do the same thing for 3000. Print quote, what is, end quote, x, and then in quotes we got to do the multiplication sign, y. What is x times y? And the computer uses an asterisk to multiply. We usually type in x to multiply, but x is the letter that's used for variables. So what is x star y is technically how we do it. Line 310, input answer. Line 3020, if answer equals x times y, then print correct, else print wrong. 3030, return. 3040, 3030, return. There is no 3040. Now 4000, last one. Print quote, what is x quote slash for division, y. And we use a slash to divide. We don't actually have that little slash with the two dots above it as a symbol on our keyboard, the actual division sign. 410, input A. 420, same logic here. I'm thinking we could have a way to simplify some of this even more and have less code and more branchable GOSUBs, but we're just going to deal with this for now. If your answer equals x divided by y, then print correct, else print wrong. 4030, return. This is a pretty cool program. Let's go ahead and run it. My math sucks, but we're going to see. It pauses for count of 600. Let's try simple for addition. Okay, what is 50 plus 32? I'm thinking that's 82. Correct. Now it goes back. Now when it returns and goes back, it has that, it's like 6-second delay or whatever that delay is each time. Okay, let's try a subtraction. What is 14 minus 66? Well, that's going to be a freaking negative number. I don't even know, so I'm just going to say 4. Okay, wrong. Okay, I'm not going to give myself a headache right now trying to do this kind of math. Let's do a multiplication. What is 45 times 34? I don't know. I'm going to say it's 129. It's whatever. It's something up there, right? Who knows? Division. What the hell is that? What is 56 divided by 30? I'm going to say 0.3. I don't freaking know. Dude, give me one digit multiplication numbers. What's 1 times 4? I can handle that. All right. Let me impress myself and feel good again. Boost my self-esteem with some basic addition here. I'm going to say that's 94. Woo, I'm a genius. I'm a genius. Top of the world, ma. All right. Hit the end key, which is my break key. That was kind of a cool program. It says, notice the word else in lines 1020, 2020, 3020, and 4020. When you can use else, if you want the computer to do something special when the condition is not true. So it's basically saying kind of like what I said, that, you know, if it equals this, then do that. If it doesn't equal this, then do something else. Now, here is a part of a program using on ... go to. Here is a part of a program. So Crazy 8's 500 hearts. Which one do you want to play? Print, this is Crazy 8's, this is 500 game, this is the hard game, and then each one of these is going to end. So I'm not going to waste time typing those in. This is a similar concept here, though, where it's going to give you a menu of choices. It's going to input your answer, and depending on your answer, it will go to a routine that will print out something acknowledging what you did. So that's kind of redundant at this point. If you guys want to type that in, knock yourself out. Now, does the job say and, or? Anyone who speaks English knows the difference between and or. Even your computer. For example, assume there's a programming job opening. The job requirements are a degree in programming and experience in programming. Erase memory. That's typing in new. And type this in. 10. Print, quote, do you have, I guess you have to do spaces, do you have dash dash 20. Input, quote, a degree in programming, semicolon, D strings for a degree, and 30, input, quote, experience in programming, semicolon, E string for experience string. Okay, now, line 40. Here's where we make our comparisons. We're going to look at an and. So we have to say, line 40, if D strings equals yes, and E string equals yes, then print, quote, you have the job, else print, sorry, we can't hire you, end quote. And line 50 is going to go to 10. Excuse me. All right, so let's run the program. Do you have a degree in programming? No. Do you have experience in programming? Yes. Sorry, we can't hire you because the requirements are we need both. So what if I lie? Do you have a degree in programming? Of course I do. Do you have an experience in programming? Yeah, let's just say no. Oh, sorry, we can't hire you because we want both. All right, do you have a degree? Yes. Do you have experience? Yes. You've got the job! Yay! Top of the world, Mom. I'm gonna be a programmer. That's when the big bucks come in. That's when all the women line up at my door. All right, so very cool situation here. But it says now, assume the requirements change so that or becomes and. And now you could have either one. So we can actually edit line 40. I don't remember how to delete. I think it's just delete. So if I edit 40, let's do this. D, D, D. Okay, now I'm going to hit I for insert. I'm going to do O for R. And then would it be clear to stop inserting? No, it's not. I don't know how to stop inserting. But let's take a look at that now if I list it out. I don't know how to get out of insert, and I'm too lazy to go back and look at the book. All right, so if D strings equals yes or E strings equals yes, then do it. So now we're going to say you can have one or the other. Either one is yes. And so if you had yes to one and no to the other, or no to one and yes to the other, it would work. If you had yes to both, it would still work as well. So if we try this again, do you have a degree in programming? No. Do you have experience in programming? Yes. You have the job, because now it's one or the other. Do you have a degree in programming? Yes. Do you have experience in programming? No. You have the job. What if I say yes to both? Do you have a degree? Yes. Do you have experience? Yes. You have the job, right? Because the or would still work, because it's saying if one or the other is yes, that's fine. If they're both yes, that condition is still a true condition. So very, very cool. So that's you know, if, and, or, then, else. There's lots of ways you can start to. And that was the cool thing about BASIC. What did BASIC stand for? Beginners All-Purpose Symbolic Instruction Code. What was that supposed to mean? It was supposed to mean it was a very easy thing for people to use, and the BASIC language is somewhat like the English language. It is what we call a high-level language, so it's not super technical, it's not super complicated. It's pretty easy to pick up on, maybe easy to learn, hard to master, depends on the individual, but it's very cool stuff, right? So when you look at these things here, print quote, do you have? I mean, you can almost look at a basic program and know what it's going to do. Input a degree in programming, D string. When you answer that, that gets calculated as a variable that will be called D. Very, very cool stuff. All right, what else do we have in this book? More arithmetic. Oh, SGN, sign, ABS, absolute, str strings, converts a number to a string, and then exponents. More stuff, more arithmetic, my least favorite thing in the world. But let's take a look at it here. Okay, so the SGN commands. So SGN tells you whether a number is positive, negative, or zero. That's kind of cool. So line 10, input, quote, type a number, end quote, semicolon, x. So we're going to ask for a number, store it in a variable that we will call x. Now, 20, if SGN x equals 1, then print positive. Line 30, if SGN x equals 0, then print 0. 40, if SGN x equals -1, then print negative. And then line 50 is go to 10. This is kind of cool. So if I run this, give me a number. If I type in 1, that's positive. 2 is positive. -4 is negative. 0 is 0. So this is, it says run the program, input these numbers here. Type in 15, that's positive. Type in -30. Well, that's negative. Type in -0.020. That's still negative. Type in 0. That's 0. Type in 0.22. That's positive, right? So positive means you're to the right of 0. Negative means you're to the left of 0. 0 means you are at absolute 0. So SGN is a way to tell where your needle on that numerical compass is. Kind of cool. What about ABS? ABS tells you the absolute value of a number, the magnitude of the number without respect to the sign. Say what? Input a number. The absolute value is ABS. I don't know what that means. I think that's like getting to the root. Like, why don't we save this? I'm going to save this as SGN because that was kind of neat. All right, we're going to do new. So this one's going to be called ABS. 10, input, quote, type a number, semicolon, n for number. 20, print, quote, the absolute value is ABS n, absolute of n. 30, go to 10. So what am I thinking this going to do? What if I type in a number like 25, that is a base of 5 that can be broken down 5 times to the root of 5? I think that's what we're talking about here. So when I run this, if I type in the number 9, 9 is a base of 3. The absolute value is 9. What about 100? What if I say 101.1? All right, I'm really confused. What the hell are you doing for me, dude? ABS tells you the absolute value of a number, the magnitude of the number without respect to its sign. All right, so if I do negative 100, the absolute value is 100. Now you lost me. So if I do 0.05, if I do negative 0.05, okay, so what is this doing for me? If for some reason I have a number that ended up being into the negatives and I was only concerned with what the number was and not where its place in the grand compass of numbers is, I could get the absolute value, which is, I guess that's what they mean there, absolute value. The magnitude of the number without respect to its sign, right? Because if it's a positive number, it would be plus 100. If it's a negative number, it would be negative 100. So we just ignore the plus or minus and tell you the number. I understand what it's doing. I'm having a hard time thinking of where this is useful in the world, but we'll go ahead and save this program as ABS, also known as anti-lock brake systems. And now we're going to do a computer thing that's going to convert a number to a string. And how can we know that we're going to convert it to a string? Let's type in new 10. Input, quote, type a number, enter that as n. And this is actually the exact opposite of val. So val would take a number that was in quotes, so a string numeric value, and convert it into a numeric variable, because you can't do math with strings. You can't say, you know, if a string is 5 and b string is 6, you can't say print a strings plus b strings, because you're going to just see the 5 and the 6, because strings are printed literally. If you converted those to their value and then did print a plus b, then you would see the sum of the math of those things. So val takes a numeric string and converts it to a numeric variable. An str string takes a numeric variable and converts it into a string variable. 20, a string equals str string, your number, and then 30 is going to print a string plus is now a string. So whatever number I type in, I'm going to now see it as a string. So when I run this, if I type in 0, I'm going to say 0 is now a string. If I run this and I type in 10, 10 is now a string. If I run this and I type in 100, 100 is now a string. All right, so we'll save this as str for whatever that's worth. Now, type in this number and run it to see how a computer deals with very large numbers. Let's do new. And this is how we deal with exponents. We started talking about this in our last example where we raised a number to its power. So x equals 1, 20, print x. Okay, 30, x equals x times 10. 40, go to 20, which is going to print x. So we're going to start at 1, then we're going to go to 10, then we're going to go to 100, and then 1,000, and it's going to keep on going. The computer prints very large or very small numbers in exponential notation. So let's take a look at that. Let's run it. Okay, see now we're already getting into the 1e38, 1 exponent to 38th time. And then I've got an overflow error because I've now created a number too big to store into a variable. The computer prints out very large or very small numbers in exponential notation. So 1 billion, which has got 3, 6, 9 sets of zeros, becomes 1e plus 09. The 09 is telling you how many zeros are following that. 5e, if the answer comes out as 5e-06, you must shift the decimal point, which comes after the 5, 6 places to the left, inserting zeros as necessary. And so 5e06 becomes 6 zeros and a 5. This exponential notation is simple once you get used to it. Don't agree with you. You'll find it an easy way to keep track of very large or very small numbers without losing your decimal point. Okay, don't agree with you. But congratulations, programmer. All right, we have finished the basics of basics. So you have learned the basics, and you can no doubt write some decent programs. The next section will help you add excitement to your programs with graphics and music. I cannot wait. What are the commands we learned in this chapter? Stop. Stop allows your program to stop running in the middle of the program. It is like forcing a break through software, not through the keyboard. Continue allows your program to pick up from right where it left off. Mem is letting you know how much memory you have. When you print mem, you'll find out how much you have. The interesting and confusing part about printing your memory had to do with how much memory you had. So this is a virtual color computer 3 that has at least 128K memory. The weird thing about the color computer is that in BASIC, it would never let you know about any number larger than 32K. But what was even stranger than that was if you had 32K, it usually printed out a number about 2,400 and change. You had like 24 something, something, something. And that was because the extended color BASIC ROM ate up 8K of your 32K. So you actually had less memory available to you in BASIC. So it was always confusing when somebody says, well, how much memory do I have? You know, I don't know, dude. But yeah, so that was kind of that. So print mem will print out how much memory you have left in BASIC. SGN. I forgot what the hell SGN did. What the hell did you do, SGN? SGN tells you if a number is positive, negative, or 0. There we go. What did ABS? Tells you the absolute value of a number. It doesn't matter if it's negative 100 or positive 100. It's just going to tell you that it's 100. STR string is going to convert a numeric variable into a string variable. And OR are pretty cool concepts where you can say if this and that equals something, then do this, else do that. Or if this or that equals something, you can look for one of two conditions or two of two conditions. And then you do then or else. Then it would happen if the comparison was true, else would happen if the comparison was not what you were looking for. And then it also explained the basic concept. That is what I consider to be a highly oxymoron here. But the basic concept of exponential notation. I don't fully grasp it. I don't fully agree with the fact that they say it's really easy to understand once you get over the fact that it's not really easy to understand. But be that as it may, when you start to print out large numbers, instead of it printing out a whole bunch of zeros, it's come up with its own shorthand that somebody thought was a great idea. I would rather just see the frickin' number, but call me crazy. But anyways, that's it, man. Chapter 13, lucky number 13. Hopefully you are not superstitious. And so I'm going to go ahead and stop recording now and start uploading this to YouTube. I hope you enjoyed this. I cannot wait to get into graphics and sound now and start doing some visual things. That is going to be awesome. Thank you, everybody who's been watching these videos, who've been leaving me comments and encouragement and everything else. It is overwhelming. Hold on. I'm gonna cry here for just a minute. Yeah. Okay. So moment of sorrow has passed. Yes. Awesome. 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 I'm excited. I want to keep going. I've got the bug. I've got the fever. And the only cure is more basic. All right, guys. We're out of here. Don't forget to leave a like, to comment, subscribe, share with your friends, and program